Up.
No, it
Okay.
was weird.
Keep it aimed at the board.
Crazy.
All right. You're my director of photography, Stephen.
Am I in the picture?
No.
Wait, oh God.
Hurry up, hurry up. Don't reach back for your hat, Indiana.
Ah.
Thank you. Okay. What does number 24 say? What is the question?
I don't remember, but the thing is XX
Can someone...
equals
Okay.
5 over 4
Mm-hmm.
minus parentheses x minus 1/2 squared.
Okay. Anybody remember what the question was?
I think it was like graph it and find the vertex.
Graph it, find the... No. Graph it and something about axes.
And
Use the
then
vertex and
domain.
intercepts to sketch the graph of each quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph to determine the function's domain and range. First off, this one's written annoyingly. I would rewrite it as -1 times x minus 1/2 squared plus 5/4. Am I allowed to write it like that?
Yes.
Good. I'm glad you agree. This tells me that A is -1, K is positive 1/2, and H is positive 5/4. Is that correct?
Mm-mm.
We get a counterintuitive shift snuggled up inside with the X. We get an intuitive shift on the outside. And A is -1 means it has the same sort of slope-like behavior as your standard parent y equals x squared, but it is frowning, I believe, not smiling. So we got a vertex at 1/2, comma, 5/4. Let's see how many questions we can answer without graphing it. If this thing's frowning and the vertex is at 1/2, 5/4, what's the highest y value it can possibly have?
Oh,
Lauren?
5/4.
5/4. So its maximum value, and when we talk about the value of a function, we're always talking about y. Its maximum value is going to be y equals 5/4. And from there, it frowns rather than smiles. So what's its range?
Infinity. Oh, wait, now.
It's frowning, and it can only go as high as 5/4.
That to negative infinity.
We would usually say it the other way, left to right. Johnny, how would you put it?
My bad.
Negative infinity, and then 5/4.
Does it include the 5/4? Yes, it does. That's the other part you left out, Stephen. But you had the right range of the, you had the right little r range of the capital R range. Range of the range? Okay, never mind. What's the domain of any parabola?
Infinity to infinity.
Negative infinity to infinity, but I understood what you meant, but you got to put that negative in there, Lauren.
Well, I do, but not when I speak.
Okay, as long as you do it right on paper. Domain is negative infinity to infinity. Range is negative infinity all the way up to 5/4, and then it stops. What else we were asked to find?
That's it.
Use the vertex and intercepts.
Graph it.
Oh, well. yeah,
Intercepts. Intercepts the let's see.
Can we
Find
have-
the x-intercepts by setting this equal to 0. Let's see what that looks like.
Oh, I hate graphing.
Okay, so that's going to be negative 5/4 equals -1 x minus 1/2 squared, correct?
Sure.
I just subtracted 5/4 from both sides. Now I'm going to multiply both sides by -1. And now I'm going to take the square root of both sides. Have I done so correctly?
No.
Yes, Lauren. Where's my mistake?
By half, it shouldn't be the entire thing be squared, not just the 5.
You change the 4 to 2.
The square root of 5/4 is the square root of 5 over the square root of 4.
Yeah, you should have told me that earlier.
I should have. That was a test.
Never mind. I got it.
You passed for noticing there was an issue. Johnny passed the test for noticing what the issue actually was. Add 1/2 to both sides, and I get 1/2 plus or minus the square root of 5 over 2 equals x. Same denominator, so I can say x equals 1 plus or minus the square root of 5 over 2.
Is it plus or minus 2, though? Because it's a square root, or no?
Stephen, I'm missing something.
You know how you have plus or minus root 5?
Yes.
Shouldn't it be plus or minus 2 then? Or did that only be plus or minus root 4?
Technically, this has happened. Okay? But let's look at this sort of like a Punnett square. Let's look at all the possibilities.
Oh,
Okay?
I remember
If you have plus root 5 over plus root 2, you can have minus root 5 over minus root 2. You can have plus root 5 over minus 2. And you can have minus root 5 over plus 2, correct?
yes.
And what do all these possibilities basically boil down to? These two will be a positive divided by a positive will get me.
Positive.
Negative divided by a negative will get me.
Positive.
Positive divided by a negative.
Negative.
And a negative divided by a positive.
Negative.
So can I sum it all up with just one plus or minus?
Yeah.
Okay, so this is very good. I'm actually really glad you noticed that. I meant to say something about that at some point. This does sum up all the possibilities, but you guys should know that this is what's really happening. Okay? Good. So these, with all this information, can you then, I mean, you've got a vertex, you've got two x-intercepts. What haven't we found?
Why?
Y-intercept. Okay? Y-intercept, I'll do over here because this is terrible board use. No, I shouldn't. I got to keep going left to right. Is this still in the picture, Stephen?
No.
Now it is.
Now it is? Okay. Sorry, that part wasn't. Okay, so now the y-intercept will be f of 0. We'll go back to the original one, and we'll say 5/4 minus 0 minus 1/2 squared, which is 5/4 minus negative 1/2 squared. So that's 5/4 minus positive 1/4. Is that correct?
So that's 4/4, which is 1.
4/4, which is 1. So the y-intercept is the point 0, 1.
What? Never mind.
Okay, this will be some hideous decimal. This will be easy. This will be annoying because it's fractions, but you have all the information required to graph it.
Yeah.
And then some.
Wait,
Yes?
okay, so is the y-intercept 0, 1, or is it that the... Oh, wait, never mind. They're different things.
The x-intercepts are technically...
No, I was thinking the vertex.
Oh, that doesn't relate to the vertex.
No, I know.
Yeah, the x-intercepts are technically these 2 points. If that's unclear. I should make sure that's clear. It's this point, which will be about 3 point something over 2, and this point, which will be negative 1 point something over 2.
That makes sense.
Squared 5 is 2.2-ish. I'm blanking on that one. Yes, sir.
Can we do 36?
We can do 36.
Yeah.
Use the it's the same set of questions, right?
How do you, for 36, how do you get from the Pythagorean theorem? No, that's
Standard.
from standard form to
Vertex form?
vertex form.
You know that 3, that's not how I do that because the 3 is there. You could do it, but that would be very annoying. I'll give you a hint on why that is. Does everyone have this okay?
Yep.
May I erase it?
Yep.
Okay. Getting to vertex form by completing the square is always possible.
Wakey.
It's not always recommended. I would use negative b over 2a in that case to find the x coordinate of the vertex. Remember that trick?
I'm looking
No.
for
Okay, I'll go over both. Okay, this is, can you read me number 36?
now. F of x equals 3x squared minus 2x minus 4.
Learn that 3. Okay, to do the completing the square trick, that only works if you have
Nothing there.
coefficient of 1. Yeah, which looks like nothing there. You can do that by changing that to x squared minus 2/3 x minus 4/3.
It's annoying.
Okay, now the first step of completing the square is you cut this coefficient in half, square it, and then wish really hard that it's what you had at the end. So you're going to be dealing with, half of this is 2/6, it's 1/3. So you're going to be dealing with 1/3 and 1/9 if you complete the square.
Okay.
That'd be annoying.
Yeah.
You want to do it that way?
No.
No.
Yeah, okay. I mean, you can, it'll work.
All right.
All right.